All right, welcome back. So one thing we're going to do is we're going to first talk about determining end behavior of a graph, right? So to graph a polynomial function, we want to know, hey, what is the end behavior? So in other words, as x goes out to positive and negative infinity, what's going on? What's going on with the graph of this function? So we're going to look at analyzing polynomial functions by looking at end behavior. That's going to be very helpful. But before we do that, one of the things we want to understand, and this is mentioned before when we talked about similar functions, is this idea of continuity, right? Being continuous. So we talked about how continuity or a continuous function is where you can basically draw the graph without lifting your pencil off the paper, right? So if you can't do that, we would say that the graph is discontinuous. But we also need to talk about the smoothness of a graph, right? So what does being smooth mean? It means that there's no sharp edges or cusps, right, in the graph as well. So polynomial functions are characterized by being both smooth and continuous, okay? So, for example, in this case here, this would be an example of a smooth and continuous function or graph, right? You can see how it's nice and smooth, no sharp edges, no cusps, no breaks. So you can see that it's both smooth and continuous, okay? Here, this is continuous. You can definitely draw it with your pencil, but this is not smooth. Because again, this would be like an absolute value function, right? It has this sharp turn in the graph. So this is continuous, but not smooth. Okay. Here, this would be a reciprocal function where we've got a break in the graph, right? Because of the asymptote, we got a vertical asymptote at x equals 0. Okay. So this would be not continuous. Okay. Here we've got this piecewise function, let's say, right? And we've got a hole in the graph. Right here we've got a jump in the graph, so this is not continuous. Okay. So just to review and reiterate what we are looking for, or not looking for, but what we understand about polynomial functions. They are both continuous and smooth.